Students, good morning to all of you. I hope all of you are well and you may something think about myself today, seeing my dress of pujari. Okay, but students, I want to say one thing that actually I went to a temple to worship gods and goddesses. At that time, I remember that, oh, I have forgot to take a class in my school. I started coming here to give you the classes. Okay, so dress is not the matter, but the education is the matter. What is your subject? What is your syllabus? That is needed. Okay? Yes, thank you very much. That you have responded, at least supporting me, that we always think of dress, we always think of classroom, we always think of cars, houses, etc., etc. But actually, we have to think of education. Okay, so now you focus your attention about your education, about your syllabus. So you know that your exam is coming ahead. So being a physics teacher, I will teach you physics like before, and today I will teach you electricity. Okay, so that's why I am writing here electricity. First question is that what is current? Okay, first question is what is current? I think all of you know. In spite of that, I say this answer. There is a rate of flow of charge is called current. So when there is a wire, as water flows through a pipe, similarly electrons flows through electric wire, right? So the rate of flow of electrons is called current. I is equal to Q by T, where Q is the quantity of charge and T is the time. When water is flowing through a pipe, surely there is some time and some quantity of water, and here is also some time but some quantity of charge. This is called current. And what is the unit of current? You know, that is ampere. Okay, so 1 ampere, so if it is 1 ampere, is equal to 1 coulomb per 1 second. In 1 C S minus 1. Okay, C stands for coulomb, A stands for second. So that's why C S minus 1 coulomb per second is called ampere. So how can you define 1 ampere? So 1 ampere is that much current which flows in 1 second having unit quantity of charge, that is 1 coulomb. So that is, if 1 coulomb of charge flows in 1 second, then the current flows through the wire is called 1 ampere. Clear? Now come to the point. The unit, what is current you have learned, what is ampere you have learned. Now come to the point. State Ohm's law. State Ohm's law. The most important discovery in physics, Ohm's law. This electricity is based on Ohm's law. That was discovered by scientist Ohm, OHM. That's why it is called Ohm's law. What is it? So when current flows through a wire, you know that has to face a resistance, opposition. As when you do something, opposition comes. Similarly, when current flows through a wire, the property of the conductor by which it opposes the obstruction is called resistance. That is, obstruction offered by a conductor is called resistance. So when current flows through one point to another point, this is A and this is B. So the potential of A is what? V suffix A. And potential of B is what? V suffix B. So the potential difference between the 2 points is what? Is as arrow is moving from this side to this side. So mind that this is higher potential and this is lower potential. Okay. When arrow will be given from this side to that side, that will be B will be higher potential, A will be lower potential. So arrow means what? From higher to lower, not lower to higher. So the potential difference between the 2 points is what? VB minus VA. So here as A from arrow is A from B, so that's why VA minus VB. Okay? VA minus VB. And according to Ohm, it is said that VA minus VB proportional to I. I stands for current, we know. So VA minus VB, that will say it is V. So V proportional to I. Okay, VA when you subtract, suppose it is 10 volt, it is 6 volt. So if we subtract, you will get a number, and that is say V. It is 9, it is 5. So 9 minus 5 is 4. So I may write it a single letter. That's why VA minus VB is V. That's why V proportional to I. And when this proportional sign is removed, we get one constant. This is the rule of variation. Not rule of physics or chemistry or anything. Rule of variation. So that's why V is equal to IR. So where this R is called resistance. This is mathematical form of Ohm's law. And this is mathematical form of V is equal to IR. Where V is the potential difference, I is the current, and R is the resistance. Okay? Now come to the point, different types of resistance. Okay? So as per Ohm's law, we know V is equal to IR. So from here we can give the definition of resistance as per Ohm's law. How? As V is equal to IR. So V is equal to IR. So R will be what? R will be V by I. Okay. R is equal to V by I. I is converted here. So there is the ratio of the potential difference to the current. It's called the resistance. The ratio of the potential difference to the current is called resistance. From this way, we can define the resistance. And what will be its unit? As potential V, it is in volt, and I is ampere. So that's why it is volt per ampere, or VA minus 1, right? Or VA minus 1. Clear? So that's why 1 unit of resistance is what? 1 ohm, 2 ohm, 3 ohm in this way. So 1 ohm is equal to 1 volt per 1 ampere. This is the definition of resistance from Ohm's law. Now come to the point. Types of resistors. Okay, types of resistors. That means in which way the resistances are connected in an electrical circuit. We know we have bulb, we have tube light, fan, AC, TV, geyser, etc. All these electrical appliances are there. In all the houses, these are the electrical instruments are there. But how does it run? Very simple. Any electrical appearance is nothing but a resistance. Try to understand this fact. Bulb, this is also one type of resistance. How? Because in bulb there is some filament. So filament is what? Nothing but resistance. So when current flows through it, it gets obstructed by that filament. Then it becomes hot. And when it becomes sufficiently hot, it gives light. In this way, we get light from bulb. Okay? So, TV, nothing but a resistance. Geyser or fan, nothing but resistance. The function of resistance is there. So how they are connected, that we want to know now. That is, if the resistors are connected this way, say it is R1, say it is R2, say it is R3. Okay, so if the resistors are connected in this way, R1, R2, R3, okay, then this is called series connection. They are connected one by one. Okay, so the equivalent resistance of these three resistors will be R is equal to R1 plus R2 plus R3. Okay, this is the equivalent resistance of these three resistors. Okay, now it is current stage. Now we have to come to point that resistors connected in parallel. In this way, if the connection, say it is R1, say it is R2, and it is R3. And this is the point A, and this is the point B. So if the resistors are connected this way, this is called parallel connections of resistors. If it is 4, 5, 6, this way you connected. Okay, these are all parallel. So the equivalent resistance of these parallel resistors is that if the equivalent resistance is R, we may write 1 by R is equal to 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so in case of parallel connection, 1 by R is equal to this one, and in case of series connection, already we have discussed that. When series connection, already we have discussed that when it is R1, R2, R3, then it is A and B. Then R is equal to R equals to R1 plus R2 plus R3. Okay, so this is the equivalent resistance in series connection, and this is the equivalent resistance in parallel connection. Without using one resistance, we can get this value, and without using these three resistance, we can use a single resistance. This is called R. Okay, and in place of these three resistance, we can use a single resistance R. So this is the equivalent resistance of this connection. So this is parallel connection and this is series connection. Okay, this is the equivalent resistance in series, that is R is equal to R1 plus R2 plus R3, and equivalent is parallel, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus R3. And all these resistances, what we have written, may be proved from Ohm's law. By using Ohm's law, we may get this derivation and this derivation too. Okay, thank you very much. Today is up to this. In the next class, I will discuss later on. Okay.